Example 2. Suppose a poll surveyed 1,200 people to determine if they think the president is doing an acceptable job. Let p hat be the proportion of people in the sample who think the president is doing an acceptable job. The White House claims that, based on this survey, over half of the American people feel that the president is doing an acceptable job. The poll found that only 47% said the president was doing an acceptable job. Create a 99% confidence interval. Interpret and comment on the White House's claim. Let's do this by hand and we'll check using technology. So step 1 is to verify the conditions. Let's make sure there are no red flags. Again, simple random sample. We have to assume they did a simple random sample. 10%, 1,200 people, certainly less than 10% of everybody. That was checked off. And let's actually show the work on this one in the large count condition, n times p hat bigger than 10, n times 1 minus p hat bigger than 10. With p hat equal to 0.47, n of 500, we plug this in, and both these conditions work out. They're both greater than 10. So using our formula to create the interval p hat plus or minus z star on the square root of p hat 1 minus p hat over n. Recall 99% is 2.576 for z star, so plugging this in is going to give us 0.47 plus or minus 2.576 times the square root of 0.47 times 1 minus 0.47 all over 1,200. Okay, let's crunch out the standard error part. We're going to get 0.014408. Multiply that by our critical value. We're going to get 0.47 plus or minus 0.0371. So we are 99% confident the true proportion of those who think the president is doing an acceptable job is between 43.3% and 50.7%. So another way to think of this is we're 99% confident that between 43.3% and 50.7% of the American people think that the president is doing an acceptable job. And since the 50% is contained in our interval, it's a plausible value. And so the White House's claim certainly could be correct. If it were not in the interval, we would have some doubt about their claim. So doing this using technology, we do the same as we did in the earlier example. Press Stat, scroll to Test, select A, 1PropZInterval, put your X, put your N, and confidence interval. Now note we need to multiply 0.47 times 1,200 to determine X. And often you'll need to round on this one. So when you put that in, it gives you a non-integer value. You need to round it to the nearest integer. And so you're going to see the interval displayed along with p hat. So our interval again is 0.433 to 0.507. Again, if we wanted to convert this back to the plus minus notation, we do upper minus lower divided by 2. We get 0.0371. The same we got as we did it by hand. 0.47 plus or minus 0.0371. Occasionally you'll be off like in the 1,000th place or the 10,000th place. We don't fret over that though. And using StatCrunch, same steps as before. Go to Stat, Proportion Stats, one sample with summary. Step 2, we're going to enter our values for the number of successes. 0.47 times 1,200 is 564. I'll go ahead and put that in. Number of observations is 1,200. Select 99% for our confidence interval and press Compute. And we get the same thing we obtained before, both by hand and on the TI. So example 3. A student wants to study the ages of couples applying for marriage license in his county. He studied a random sample of 94 marriage licenses, found 67 cases. The husband was older than the wife. So do the sample data provide evidence that the husband is usually older than the wife among couples applying for marriage licenses in that county? And explain briefly, and let's justify our answer with that. So we're going to start by finding the point estimate. So in this case, 67 over 94 is 0.713. That's going to be our p hat. So 71.3% of this sample of 94 marriage licenses, the husband is older than the wife. But due to sampling variability, so a different sample of 94 marriage licenses, that's going to result in a different proportion. So we want to find an interval of plausible values after checking our conditions. So simple random sample, that checks out. He took a random sample, 10%. We're assuming that 94 is less than 10% of the entire county. And then we're going to check our large count condition, again with p hat being 0.713. 94 times 0.713 is bigger than 10. And 94 times 1 minus 0.73 is bigger than 10. Where you have to watch out for this is if our sample proportion is super high, like 0.98, or really low, like 0.001. And or we have a small sample, like a sample less than 30. We got to be really careful about that. So using our standard formula for the interval, now we need to decide what level of confidence we want to run. Let's run a 95% confidence interval. This is very typical, 95%. Very typical in social sciences to use a 95%. So let's use that. We're going to have a z of 1.96 for a critical value. Plugging that in, we're going to get 0.713 plus or minus 1.96 on the square root of 0.713 times 1 minus 0.713 all over 94, crunching out. That standard error term is going to be 0.0466575. Again, I'm cautious about rounding that too soon. Multiplying that gives us our margin of error, which is 0.0914. So, adding, subtracting that from our point estimate, we are 95% confident that the true proportion of marriages in this county where the husband is older than the wife is between 62.2% and 80.4%. Or another way to think of this is we're 95% confident that between 62.2% and 80.4% of marriage licenses in this county result in the husband being older than the wife.